Wait, what was 3 equals 4? That means number 4.
I hate you.
Only you're allowed to kind of say this one.
Bridget, you should do the thing. The figure 8. Yeah, keep doing it. Just like that. No, that's not.
You're not going fast. Okay, wait. Did you study the games?
I already did it.
Oh, don't even ask her. Just turn it on.
Alright, for number 1. Number 1 says something about P is the number of fish in thousands. That means when you solve this, you either need to put each number in thousands, so 6,000, 8,000, or make both of them single digits. So you can have it like this or like this. Don't do both, but do one of those. If you have 1,000, like 8,000 and a 6, or 6,000 and an 8, it won't work. You get negative numbers. They will both work out to be the same answer. So I'm just going to go ahead and do this one. We need to get T by itself. We're trying to find how many years. So multiply by your denominator. And then at that point, you have a couple of choices. You can either divide by 6 and start solving it like that, or you can distribute and solve it like that. I'm going to distribute. We're trying to get everything away from T, so subtract, divide. Once you've done everything you can algebraically, then you could do ln of both sides to get rid of e. Ln and e cancel. This just gets brought down. That was one option. You didn't have to choose. And then divide. I don't remember what that was, like 3.1. It's 3.1, but you're rounding up anyway. So round up to 4. Oh, yeah. Factor, yeah. For number 3, we have to simplify. Wait, I need to go back. Alright, I need your attention back up here. In order to simplify this, because we are dividing a fraction, we need to multiply by the reciprocal of this fraction. You could have done this in the same step. I'm just going to rewrite it first. And then in order to cancel anything out, you need to factor each polynomial. Oh. So this polynomial would be 5 and 2. I was like, This one you can factor out in x. This one would be what? 6 and 2, both negative. This one we can factor out another x. And then we can factor that again because of difference of squares. Yeah. I'm just going to rewrite the whole thing. Right, and then think of everything in both numerators as the entire numerator, everything in the denominator as your entire denominator, and you can cancel out like factors. So those would cancel, those would cancel, those would cancel, leaving x plus 5 over x squared.
I'm doing it right now.
Make sure you have this answer written down for 3 and this answer written down for 1. And then pass up your answer sheets. Am I missing anyone else?
Okay, but can we talk about punching? Dude, I'm telling you, I have this all through.
I'm just going to show you what the last couple of answers look like on the notes from yesterday.
Yeah, do you need it?
No, when I have a thing, I was writing down because I was lazy.
No, yeah, that was
Stop.
last quarter. Sorry.
But I do need your attention up here. Alright, so remember that if your domain is not restricted from negative infinity to infinity, you're still solving the same way. You're still getting the answers the same way. I don't remember which two I did. I want to say these two, but whatever your answers were, depending on the period of the function, you either add 2 pi k or add pi k. So I think these two we didn't do, I did on my own. So after you solve them, you end up with pi over 3 and 4 pi over 3, but the period of tangent is pi, repeats itself every pi. So you would add pi k to both. For 20, that was one of your Pythagorean identity types. So once you solve that, Lauren, please stop talking. Once you solve that, put your Pythagorean identity n got your answers, just add 2 pi k to that. But in this case, you don't need to add 0 plus 2 pi k. You could just put 2 pi k. It'd be the same thing. Questions on that? So 20. So anytime you see negative infinity to infinity, you're just adding plus 2 pi k or plus pi k at the end.
Well, I have a question about the homework.
We do need to go over that too, yes.
On the homework, you like told us not to include 2 pi, but
That was my question. That's so good.
2 pi as one of the answers, so do we not?
Yeah, that's okay. Because I didn't put them on there, so that's okay. If you included 2 pi, that's fine. Okay. Because I don't know who did what, I'm just gonna let you look at them. And I'll just keep scrolling down. So, because I didn't put restrictions on these and I included 2 pi, number 1 had 5 answers, 2 had 3 answers, three really just had 2 answers. NS is no solution, so does not exist, no solution, same thing. 4 really only had 3. I just wrote one of them 2 different ways. Five had 1 answer. This one was no solution. Yes.
Why did you write those 2 pi differently?
Just as another way to write it. Because they're the same, it'd be either one. For 6, there were 3 answers. I also haven't updated this for this year. This is the same one I did last year. Seven had 4 answers. 8 really had 2 because 1 didn't exist. 9 had 4 answers. And 10 really only had 1. Do we have questions on any of these? The type 4, remember I said if there are 2 terms that are squared, you can choose. So I have both of those up here if you did it one way or the other. But the pen I wrote in was super thin, so. So on the back, if you did 1, it had 2 answers. One of them didn't exist. Oh, this is number 3. Okay. 4 had 4 answers. Anytime I'm doing it differently, I change the color. For number 2, there were 2 different ways you could have approached it, but you should have got the same 3 answers. Same thing for 5. There were 2 different ways you could have approached it, but you should have got the same 4 answers. I think 3, I did 2 different ways. And you got 4 4 answers, and 6 had 2 answers. Here.
On the quiz, are we gonna be given the Pythagorean identities, or do we have to know them?
You need to know the main 3, or at least sine squared plus cosine squared equals 1. Because if you divide everything by sine, you'll get another. If you divide everything by cosine, you get the other. So if you at least remember sine squared plus cosine squared, you can find the others. But you'll need to know them. Okay. Any questions on this side of the homework? I gave you guys the notes that we're not going to do very much of today at all, and we'll continue that Monday, but I just want to get some definitions so that they're in your mind. One of the things I gave you is going to relate to your inverse trig function, so I want you to go back to that, refer back to it. Alright, so thinking back to when we first did inverse functions in general, it's inverse only if it's 1-to-1, which means it passes what test? It passes the vertical if it's a function, the horizontal if it's 1-to-1. So really it passes both because it's 1-to-1. Now, if we're thinking about our trig functions, will sine and cosine continue on forever and ever. So they are not 1-to-1 as is. But if we restrict the domain to a certain piece, then it would be 1-to-1. Same thing for tangent, because it's periodic, it repeats itself over and over. Same thing for cotangent and cosecant and secant. If we restrict them to just a certain piece, they would also be not secant, cosecant, sorry, just the other two, cotangent and tangent, they would also be 1-to-1. I don't remember if we talked about this or not. Anytime you see arc sine or arc cosine, arc tangent, or if you see sine inverse, cosine inverse, tangent inverse, those are the same thing, not separate things. So if you see one thing as arc whatever, and then you see another thing as sine inverse, same thing. We should be thinking the same thing. We're not going to get into the ground today. That's why I said we're not going to do much of this at all. Okay? So we're going to stop there, and we'll pick up with this Monday.